In the late 1600s, Isaac Newton conducted a series of experiments that broke the two most fundamental rules of eye safety. In one, he stared at the sun, and in the other, he stuck a needle under his eyeball. Newton was hoping to better understand the lights and colors that sometimes appear when your eyes are closed. If you've ever sat around an evening campfire or, unlike Newton, unintentionally glanced at the sun, you may have noticed illuminated patterns briefly dance along your vision before fading into darkness. So how do these visual illusions, known as afterimages, form? Inside the retina, specialized cells called photoreceptors take in light and turn it into a signal the brain can understand. Photoreceptors contain thousands of molecules called photopigments, which are sensitive to particular colors. When a light photon strikes a pigment, part of the photopigment structure, known as chromophore, absorbs the energy by temporarily altering its molecular structure in a process called bleaching. This reconfiguration induces a cascade of chemical reactions that route an electrical pulse to the brain. And once your brain assembles the signals from approximately 200 million photoreceptor cells, you see an image. So how does this lead to an afterimage? Scientists aren't quite sure, but a leading theory suggests that photoreceptors may be to blame. Looking at something bright causes many pigments in a photoreceptor to bleach. In this state, photopigments can't absorb light well and need to regenerate. However, it's believed that photoreceptor cells momentarily continue to fire and to send signals to the brain, transforming the blazing campfire to a bright pattern as you close your eyes. This is known as a positive afterimage. Positive afterimages normally fade within a few seconds and, under certain conditions, can be replaced by what is known as a negative afterimage. The original colors appear to be swapped for their approximate complement. Blue with yellow, red with cyan, green with magenta. If you fixate on a bright image of a green flower on a yellow background, then glance at a white screen or close your eyes, you will see a negative afterimage of a magenta flower on a blue background. Scientists are still working to understand the origins of negative afterimages, and there are multiple theories. Some evidence suggests the source lies in the layers of neuronal cells in the retina called ganglion cells, while other research implicates deeper processing in the brain. Another theory suggests the source lies, again, in the photoreceptors. The idea is that certain cells are activated if one color, such as green, is viewed. Meanwhile, other cells that are normally activated by viewing red, green's complement, are then left deactivated. But if you stare at a green image for an extended period of time, it's thought that while the activated green cells become fatigued, the red cells are still sensitive to input. As a result, when you look away or close your eyes, the opposing red cells are momentarily more active than the tired green cells, creating the perception of a color that is close to the original color's complement. But scientists still don't know for sure. And yet another puzzling visual illusion involves no light or staring at all. Simply rubbing, or like Newton, inadvisably stabbing behind your eye, can generate the brief appearance of lights and colors. These are known as pressure phosphenes. Newton hypothesized that the colorful circles of light were caused by the physical bending of his retina. Today, some scientists believe that pressure phosphenes are indeed the result of distortion, that rubbing or poking your eyes physically stretches neurons, bending the photoreceptors out of shape and causing them to fire. But again, the science of phosphenes is far from settled, and there are other ways they can form. For example, during procedures where magnetic pulses are sent into specific parts of the brain, some people, including those with certain types of blindness, report seeing flashes of light. And astronauts traveling where few others have gone before often describe seeing similar effects when exposed to cosmic radiation from the sun and other stars. What about those shadowy shapes you see floating across your vision when you look at something like a blank screen or a bright sky? Are those moving shapes inside your eye or on your eye? And what exactly are they? Find out with this video.